This is the landing page of ClimateData.ca. From here, you can start exploring available climate data by location or by climate variable through the Quick Start menu on the right or the tab at the top. For French speakers, you can change the language settings from English to French in the top right corner. Let's start with location. Here you can input the name of your city or town and select from the recommended list of options. The portal recognizes quite a comprehensive list of cities or towns, but if you find that your municipality is not listed, then input the name of the next closest city or town that is available. Later, I will show you how to change your selected location on a map to better represent your municipality. Once the location is selected, you will be brought to a summary page that looks like this. On the left is a very quick written summary of the historical and projected climate for the selected location. On the right is a map that identifies in red the grid cell that the climate data presented here has been retrieved from. This represents one 10 kilometer by 6 kilometer grid cell that covers the entire country. And for those of you familiar with the City of Toronto, this grid cell does not encompass the entirety of the city's municipal boundaries, but sits more or less in the middle of the city. If you're interested in understanding the climate of a more specific location within the city, for example, along the waterfront or in the northwest or northeast corner of the city, there is an option to select other grid cells, which I will show you in a moment. If we scroll down on this page, we'll find the option to explore annual values for our selected location for different climate variables, including temperature, precipitation, and other variables. You can explore different climate variables by using the drop-down menu. A brief description of each climate variable is provided, along with why it is important and its technical description. If we scroll further, we'll find a graphical summary of the selected climate variable for Toronto, which in this case is temperature data for the hottest day in the year. The graph is interactive and starts with modeled historical data from 1950 to 2005. Modeled future data for 3 climate change scenarios starts from 2006 to 2100 and includes a very low emission scenario, RCP 2.6, a moderate emission scenario, RCP 4.5, and a high emission scenario, RCP 8.5. The bolded lines in the center represent the median across the modeled values under each scenario. The shaded regions represent the 10th and 90th percentiles of the modeled values, or 80% of where the modeled data fall within. If you ever need a refresher, you can select the How to Read This button at the top left corner of the graph. Please keep in mind that this climate data portal is continually being updated. New climate variables may be added or modified from time to time, and new climate scenarios are also on the horizon. You can toggle the different datasets on and off by selecting the legend at the top. For example, if you only want to focus on the highest emission scenario, you can deselect RCP 2.6 and RCP 4.5. The gridded historical data is turned off by default. This is the observed historical data that has been interpolated for the entire country. If you want to display or download this data, you have to ensure that this item in the legend is selected. From here, there are several options. If you select the chart context menu icon in the top right corner of the graph, there's an option to print the chart, download the graph as an image, or download the underlying data as a CSV Excel file or SLX Excel file. Only the datasets selected will be downloaded, which in this case includes gridded historical data, modeled historical, and RCP 8.5. There is also an option to view this data on a map by selecting the View on Map button on the right. This brings us to a gridded map. It is automatically zoomed into our selected location of Toronto. If you want to change your location, select the name of your current location at the top left corner and type the name of another city or town, for example, Essex. But for this example, let's continue with Toronto for now and we'll revisit Essex later. Right now, we're viewing the hottest day in a year for the time period of 1971 to 2000. If we move the slider at the bottom, data for a different time period will appear on the screen. You can select the future climate change scenario you want to view by using the drop-down menu at the top whether it's RCP 2.6, 4.5, or 8.5. This portal also has a neat feature that allows you to compare two different climate change scenarios together. For example, RCP 8.5 versus RCP 4.5, which will display the data side by side. You can change the opacity of the layers at the bottom right corner. You can also zoom in and out using the plus and minus signs at the bottom left corner. You can change the temporal unit of the data from annual to season or a month if data is available. For the hottest day, you can view the hottest day in July, for example. You can also view the data in terms of the delta change or difference compared to 1971 to 2000. In this case, we're seeing how much hotter the hottest day in July would be in 2071 to 2100 compared to 1971 to 2000. You can also explore all available climate variables through this map by using the drop-down menu at the top. And if you want more information or a refresher of what the climate variables mean, you can select the information icon within the drop-down menu. If you ever need a refresher on how to use this map, select the Take a Tour button at the top right corner. Apart from gridded data, this climate portal also offers climate data at other spatial units, including census subdivisions, health regions, and watersheds, which allows you to obtain or compare climate data at different scales. Let's go back to retrieve data for the entire city of Toronto. Under census subdivisions, we would select the city of Toronto on the map. This brings up a familiar graphical summary for the entire city of Toronto for the hottest day in a year. But here we see that we have several additional options. We can view and download the annual values, or we can view and download the data as 30-year averages or 30-year changes by selecting the options at the top left corner of the graph. We can download the graph as an image, or we can download the data as a CSV. But again, remember that only data that is selected will be included. So if you do want to include the gridded historical data, remember to select it. From here, you can view and download the data for different climate variables and climate change scenarios. This portal also offers data that you can customize for several variables. For this option, you'll have to go to Analyze at the top of the page. First, you'll select a dataset, which there is only one of at the moment. Next, you'll select a location. For this example, let's use the town of Essex. So we'll go to Census Division and type in the name of our location and select it on the map. You'll know that it has been selected when it appears red on the map. If instead of the town of Essex, we want to look at the county of Essex, then the health region, which covers Windsor and Essex County, may be more appropriate. Next, we'll select the variable we want to customize. Here, you can customize thresholds depending on the purpose of your analysis or existing thresholds used by your municipality. For example, instead of the given thresholds for wet days as 1 millimeter, 10 millimeters, and 20 millimeters, maybe you have a slightly different threshold for wet days. For this example, let's go down to heat wave total duration. Here, we'll use the thresholds used under the Harmonized Heat Warning and Information System for Ontario, which triggers a heat warning when maximum temperatures exceed 31 degrees Celsius and minimum temperatures exceed 20 degrees Celsius for 2 or more days. We'll then select a framework, let's say 1950 to 2100. Under Advanced, we can customize the climate change scenario we would like data for, the percentiles we'd like to include, the temporal frequency, and output format. Once completed, enter your email address and you'll receive an email to download the data when it's ready, which usually takes 30 to 90 minutes to prepare. Repeat this process for any other customized climate data you'd like to retrieve data for. In addition to downloading data for customized variables, this portal also offers some additional data download options. For this, we'll have to jump over to the download section at the top of the page. Under variable data, we can download climate variable for more than one grid cell. We can also download daily data for three climate variables: minimum temperature, maximum temperature, and total precipitation. Under station data, we can also download observed historical data from one or more climate stations. Under IDF curves, we can download historical intensity, duration, frequency curves produced by Environment and Climate Change Canada. And under AHCCD, adjusted and homogenized Canadian climate data is also available for download. That brings us to the end of our quick tutorial on how to access and download data from ClimateData.ca. There are also additional learning resources under the Learning tab at the top and under Sector for those of you interested in sector-specific resources. There is also a dedicated support desk that can assist you with any questions you may have online or via the phone. Select the Have a Question button at the top right corner to enter your question and have fun exploring the available climate data. Thank you for watching.